Hey Alina, did you need anything?
Hello, Professor. Yes, I was
Wait,
calling you
wait,
because
wait.
I was.
Now I'm ready. Much more comfortable. So, move on.
All right. Yeah, I was calling you because I was absent for most of your classes about periodicity.
Yeah, you were sick for about 2 weeks. Are you fine now to
Um,
go?
yeah, I think I feel fine now, Professor.
Alright, then let's get started.
Thank you. I went over some chapters from our textbook, and I think I know what we're required to learn.
Yeah, don't worry, once we go over this meeting, you'll be able to learn more about the required materials.
All right.
So, the halogens are the 6 elements within the 17th group of the periodic table. They're the only family with 3 states of matter at SATP. Furthermore, the halogens are very reactive, especially when in contact with the alkaline earth metals. Do you have any idea why they are so reactive?
I think they are very reactive because of how they are more readily available to accept one electron to form one full valence shell. Aren't they the group closest to the noble gases?
Correct, they just need one more electron to become stable.
Right. By the way, I took a look at the table you posted in Google Classroom and noticed that it said fluorine is the most reactive compared to all the other halogens. Why aren't the other elements as reactive as fluorine?
Well, this is due to decreasing electronegativity as you move down the group. Fluorine with the highest electronegativity, highest reactivity. Electronegativity affects reactivity because it is the measurement of how well an atom is able to attract electrons to form one octet valence shell.
So, electronegativity is an atom's ability to attract electrons, but why does it decrease down the group?
It is because of increasing atomic size or radius as you move down the group. Notice how there's more and more protons and electrons as atomic number increases down the group. There will be, of course, more electrons and protons, thus bigger atomic size or radius. However, this weakens the nucleus's ability to attract electrons, which is essential for electronegativity because there are more electrons in the way of accepting any non-bonded electrons. They're more likely to repel it.
Right. That is very interesting, Professor, but how is it that the halogens contain 3 states of matter at SATP?
Very good question. That is again because of increasing weight, or I mean increasing size, which means increasing weight. As atomic weight increases, there are stronger intermolecular forces because there are more electrons for electron distortion in the electron cloud. You see fluorine as a gas, but as you move down the group, you see solids and liquids because of increasing intermolecular forces. Therefore, boiling point and melting point also increases down the group.
Right.
So, have you gone over ionization energy yet in chapter 10?
Yes, I have. Isn't ionization energy the amount of energy required for a valence electron to be free from its atom? But, Professor, does ionization energy vary as we move down the group?
Of course it does. Ionization energy decreases down the group. Do you have any idea why?
I'm not really sure, but is it because of increasing atomic radius?
Yes, that's true. As you move down the group, ionization energy decreases down the group because of increasing atomic size because the valence electrons are getting further and further away from the nucleus. There's not that much attraction, so you can free those valence electrons with lesser and lesser energy. So, thus ionization energy decreases down the group.
Right. Also, I was reading chapter 10, and I saw that it had mentioned the properties of fluorine, the most common halogens. But would it be possible for you to explain those properties?
Very well. Fluorine is very reactive, more reactive than the other halogens. It is very corrosive, flammable, and it is a pale yellow diatomic element. It reacts with water vigorously to create hydrofluoric acid, which is very corrosive. It is much more abundant in the Earth's crust than the other halogens.
All right, Professor. Thank you. This helped me a lot.
Yeah, don't worry, Alina. If you need even more help, please contact me through Zoom.
Yep. Thank you.
All right. See ya.